Link the information on, on Friday day, like first thing today, symbolism, sustainability. Senior flight show, all doing Wednesday, March 15th. Link with an email. Yeah, they received the still voting. Today they start voting next week. Enter by space.
Take me nowhere.
Contact Mr. Lightberg if you have any questions or fundraiser for former speaker Wood. Seniors gather till next Wednesday. Graduation. 3:15. Today's the day. Register the deadline. Plan on taking the ACT test on April 15th. Have to be registered by today. As a reminder about next week, third quarter ends Wednesday, March 15th. You have spring break, March 16th to 17th. No school next Thursday or Friday. It's all too standard play.
The United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for
You solve it however you're going to solve it. We got methods. The important part is that you solve it, not your neighbor, not your group. I'm guessing most of us took the path of least resistance. Is anyone still going? Okay. Yeah, it's 10 minutes. Still see some pencils wiggling. How we doing? Okay. It is factorable, but you got to do that split term method. And it gets kind of messy. You got to distribute back into a thing that you factored out. And again, it's not something I'm going to require you to do. It's just every now and then, if it's not terribly difficult, I'm going to show you. Most of us, instead, and this is the way that most of our textbooks, most curriculum, most classes you go through are going to show you, is you do the rational root theorem, all the factors of 12 over all the factors of 2, write them all out. And then you say, those are my possible rational zeros, and you do Descartes and you find out how many positive and negative possibilities there are for real zeros to determine what you guess and check. And as you guess and check, you use the lower and upper boundary theorem to continue narrowing down your options. Meanwhile, in the 21st century, I'm just going to guess really good. Like, how am I going to know any different when I see your work, because you do need work? How am I going to know any different between someone who just happened to guess -1 on the first go versus someone who tried 9 different options before hitting -1? right? So I say that we've got our coefficients for synthetic division. Frank, wake up. And say, you know what, I'm just feeling really lucky about -1. And go -2, -7, 7, 14, -14, -12, 12. Yay, it works. And say, I got a feeling because factors of 12 over factors of 2, I'm guessing 3/2 might be an option here. So I get 3, -4, half -4 is -2 by 3 is -6. 8, half of 8 is 4, 4 by 3 is 12. Yay! Now, got to remember something here. That, where'd it go? If I divided by 2 here, if you want to write this as 2x minus 3 instead of, stop that, instead of 2 by x minus 3/2, they are going to get you the same result eventually. I would need to do this. 1, -2, 4. And that's important because this is x squared minus 2x plus 4. And last I checked, there were no factors of 4 that added up to -2. There were no more real zeros that I could gaze into that crystal ball and find. So how do I find my other zeros? Ew. I'm going to complete the square. You do you. Okay. X squared minus 2x equals -4. I'm going to, half of -2 is -1. -1 squared is 1. I add 1 to both sides. So we're going to have a x minus 1. The quantity squared is -3. Solved by square roots. X minus 1 is plus or minus root of 3i. All together, we're going to have x is -1 3/2. When I add that 1 over, 1 plus or minus root of 3i. Square root of 3, or square root of -3 is root of 3 with an i. Imaginary. That was the whole point of learning imaginary numbers in Algebra 2, is it unlocks the rest of math. I can't construct a quartic using only real zeros all the time. Sometimes it got to be imaginary.
Can you show us how you write the imaginary one if you were writing it as a factor?
Oh, if you're going to write these out as factors, and that's some of what we're doing today too. The factored form for this would be x plus 1, 2x minus 3, or x minus 3/2 with the 2 out front. Either one. If I'm writing factors here, they ain't going to be pretty. It's going to be x minus 1 plus I root of 3, or root of 3i, x plus 1 plus I root of 3. Oh, yeah. Right? No, I just put them in the wrong spots. No, that's 1. It's just in the same spot. There we go. There would be your fully factored form. And it's ugly, but sometimes ugly is the only way that we're able to make these. Okay. The homework, I had a question that was self-answered. Like, how do I do? Oh, wait, there it is. So I think what we were seeing out of yesterday's stuff was, I know how to do it, but man, that takes a long time. And you got to slow down. You got to watch all your arithmetic. Like missing a single negative early on just foobars the whole thing. So that's where we left off. Do I have them? Well, they're all in the shared folder. Yeah. Okay. We did this one, right? Yeah. Okay. Notice this one, they said 4i. They only said it once. That means I have to know there's a negative 4i that goes with it. Sometimes they're going to be nice and they'll just straight up tell you both the 0 and its conjugate. So no, you are not going to do 2 root of 3 with negative 2 root of 3 and then negative 2 root of 3 with positive 2 root of 3, making this a degree 6 hexic polynomial. You just, oh hey, they gave me that one. Good job. But they didn't give me this one, so I have to know that there's a conjugate that goes with it. Okay? So just, if you ever are given 2 zeros that are conjugates, assume they don't want you to then find the conjugates of both. Okay? So this one will be a degree 4, a quartic, when you're done. You have two options. Option 1, x minus 2 root of 3 times x plus 2 root of 3. Actually, 3 options. X minus 1 plus I, x minus 1 minus I. And go distribution bonkers on it. This is how we did it in Algebra 2, unless your teacher gave you the cheater. Option 2 is, each of these is written as 0 plus 2 root of 3. There's a 1 in front of this I. I can say that A is 0, B is 2 root of 3, and use the radical form cheater. I can say A is 1, B is 1, and use the complex form cheater. So instead of all this, if I want to distribute all this, the quadratic that I will get is x minus 2 by a thing, x squared, plus a squared minus b squared, x squared minus 2ax plus a squared plus b squared. Minus when there's a radical involved and no I, plus when there's I involved, because the I is a radical. Okay, and I would plug in those values. 0, 0, 2 root of 3 is the entire b term, the entire radical term. 1, 1, 1. So whether you're going to do blue-green or purple, finish it off. Get that basic distribution skill going. If you want to stack multiply, if you want to do them in tiers, tiers T, was it IE or EI? I've screwed that rule up since like 3rd grade. And then they list 12 exceptions. So I remember that I remember it wrong, but then I do it wrong knowing that I'm going to do it wrong. So that I remember I remembered it wrong, so I do it wrong knowing that I'm going to be wrong. It turns out now I'm just wrong. Right? Right? Okay? Tiers the ranking, not tiers do your math in tiers while balling. Okay? Okay. And the more you write it, the more it doesn't look right.
Either way, they need to see an A.
All right, that's pretty good. But no. Okay? So you need some form of multiplication organization for this. Okay? You need organization. So the whole point of that cheater was that if you want to avoid all of that multiplication to get here, x squared minus 2ax plus a squared minus b squared by x squared minus 2ax plus a squared plus b squared. If I were to plug in 0, 0, what's that? 2 root of 3. If I were to plug in 1, 1, 1, okay, I can avoid all of that multiplication for the first round, finding the quadratics, by plugging into those formulaic patterns. Conjugates always do this. So whether you go purple-blue distribution madness or yellow-blue plug and chug, you should get those green quadratics. I ain't going any further than that. It's just, we should get the quadratics and then multiply those out. But we got to make sure we have the correct quadratics to begin with. Whenever this problem comes up on tests, oh boy, the number of kids that get like 9 out of 10 or whatever it is on that problem, and they just got one marked off domino. So the consensus from yesterday was that some kids have seen that cheater before, but not everyone. I think we were under 50%. That is some power type in there, child. You got the whole thing done?
Yeah, it's done.
Okay.
I did
All right. I'm just checking. Like those are thumbs of fury right there.
I wrote I did it and I drew a heart.
Okay. So the purple blue stuff is how most of us probably did this in Algebra 2, where you'd write out the definition, x minus the 0, and then go distribution bonkers on it, getting to green quadratics.
I don't know what I don't even know.
Where are we starting?
Well, I got the 2, but then I just plugged them up in here. Well, that was my goal. I plugged
Oh,
them
no.
in.
Okay, you're missing the conjugates that go with them?
What do you mean? I thought you just plug them into these formulas.
Okay. If you have this, you have this, right?
Mm-hmm. Yeah.
If you're doing this,
Then you're using that.
the compound's 0 is 0 plus 2 root of 3.
But I thought you'd have an x in there.
That's if you're going to do the definition with factored. Technically, it's x minus this. The 0 itself, a and b, are what go in there.
So I don't need to even set it. I don't even need to like put x in there at all. I can just go straight from there to there.
Yep.
Okay.
Yeah, you're kind of like stuck in between those two methods. Okay, so most of us are going to start to appreciate, get rid of all this, and instead just start the problem with, what? Oh. Be that way. Like this. Okay? Most of us are going to appreciate just doing that instead of the first stage of distribution. You still got to finish it off. I still have to say x squared times all that stuff, and negative 12 times all that stuff. Okay. Now, I just multiplied these two things to get this quartic, correct? I should be able to, this is kind of leading ahead, but just while we're here and we have the, screw you, Frank. While we're here and we have this, if I gave you this polynomial and then said 2 root of 3 is a 0, could you go find all the other ones now? If 2 root of 3 is 1, then negative 2 root of 3 is 1. So off to the side, I'd say x plus 2 root of 3, x minus, 2 root of 3. Numbers, hard. And get x squared minus 12. Well, if I have that quadratic and this quartic, I could then x squared plus 0x minus 12 divide longhand, and I would get the other quadratic, x squared minus 2x plus 2. Then I would dump that in the quadratic formula, and I'd have all my zeros. You should be able to work forwards and backwards between polynomial and zeros. Okay? Now, we're not going to do that yet. We need to practice this. Can I even make the polynomial? I added things. It was negative 10 or positive 10x squared in the middle. That was the only like term that the two had. Which part?
How does it get two? I only got one. Right there at the end.
Because you're missing the entire other part of it.
No, that's the b squared. I'm right. That's b squared.
So where's a squared?
Okay, wait. X squared. Yep, have that. Minus the 2 and the a, which is 1.
Uh-huh.
X, so yes, minus 2x.
Mm-hmm. Plus a squared, so 1 squared.
Plus b squared. Oh, so I kind of forgot that complete other. Yep, I see now. Thank you.
And we're back. It's just missing a thing. All right. Dun 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 dun.
On Zoom.
Create the cubic that has these 3 zeros. And I'll tell you, y'all, hey, chill out. Aren't these both over 2? Isn't that a lot easier if I write it like this? So I see my A and B. A plus BI. I have an A and a B and a formula. It's not nearly as difficult as it looks. Go.
I'm really scared.
And that is why you fail.
So we use the radical sheet or the.
I supersedes radical.
Okay.
The radical one has a different sign because it lacks the I to change the sign. They're both doing the same conjugate stuff. It's just one of them gets a sign change because of I. The I one plus. Yep. What's that? X squared minus x. That squared is 1/4. 1/4 is 5 11/4. 12/4 3. X squared minus x plus 3. And then x plus 5. Come on, you.
So this is the cubic. Should be in there.
5 by
Versus
1/4.
I wrote one.
5. 6.
So do you not have to do the inverse of -5?
No, because it's not a compound or complex number. Remember, that's just a plain old -5. It does not have its conjugate because -5 doesn't have a conjugate.
On this one, did you only do this for one of these two?
You have the first part.
Yeah, because they gave you the conjugate.
Is this
I'd said if they ever give you the conjugate, assume that they're just giving you both instead of if I have this, also do the negative. If I have this, also do the positive.
Okay, so why do you only have to do the one though? For this.
Because if I have two radicals, it will create a quadratic, right?
Oh, okay.
I have two radicals, the positive and negative version, I will get one quadratic out of it.
I got a question.
Mm.
I'm like or squaring radicals, so it's square this.
Regular 11, yep.
So it's 11 over 4.
I didn't know.
BI. A plus B, I. The B is the thing in front of the I. Don't put the I in there with it. No, stop it. No, no I, no I.
No I. No I.
To the third plus
I don't know why I put
squared
the I in
minus
there.
2x plus 15.
So it's just that.
What's 1/2 squared? 1/4. What's 1/4 plus 11/4?
Oh, then yes.
Well,
There's
so,
not,
yeah,
there's not
I,
an X.
I'm
There's
gonna
not
ask
an X
him.
there either.
because I see, okay,
It's
I see where I went wrong, or where
12 fourths, which is also.
Mm-hmm.
Yes.
Yeah.
That's right.
Now distribute that.
Mr. Sullivan, I just need to know what I.
Oh, I did it in my head. I might be wrong.
We got the same thing up until after that.
That's right. That's right. Square minus x and 3x and it's 5x, negative 5x squared plus 15.
Maybe I just added.
No, I just missed negatives here.
Okay.
I did mine in my head, dude.
So I did do it right?
Yeah, looks right. Which is why that question mark plus disclaimer is there.
Isn't it square root of 11 I on top?
B is the coefficient of I. Don't put I in there.
Oh, that's not my thing. I don't do that.
Because all of that I business cancels out, and the I squared at the very end is what changes this sign to a positive between A squared and B squared. You have the skills to do this. You did all of this stuff in Algebra 2. It's just we're taking all of the big stuff and putting it together. Now it's in one problem. Now it's a little more complex. Now you have fractions, radicals, and i's all over the place. Also another reason that you should have been working in simplified radicals ever since Algebra 1. so that this is more familiar. Okay. After seeing it, are we okay? All right. We're going to pull some numbers out of an orifice here and see what happens. Because this is way too easy. No, 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 no. No, 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 no. You know what really messes with things? Incompatible numbers, like primes.
I say like 4. 2, 4, 6. 2, 4, 6. I like what?
Is that an I? Or is it?
Yeah. Not like a comma, like I put all of them.
Maybe I used to say it. Shut up. 7 minutes. How about you?
Go!
She's gone power hungry.
Those eyes.
Those eyes are
Oh, I suppose this is just like a semicolon, but here.
No, it's okay.
So instead of the 10 that's there, I want you doing this. This is the new 10.
Breathe.
You know what's going to make it worse? If I tell you there's a dot in the lower left corner of that board that's been there for the last 10 minutes.
Oh my god, I just saw it.
This is the only class I'm here for today. Don't make my life a I would like to have a nice car now. So I'm
Fundraising. She's gonna have nightmares now. Just because of that. Just because of that?
No, there's more to it, but like, look at that. That's so uncomfortable. It's like saying, oh, I'm gonna write a 2, and then I'm gonna write a 2. Like, I know, but like, it's just a thing, and like, I'm like saying, oh, this T can have a tail, the other one's gonna be a cross. That's so uncomfortable. Thank you. That makes me really happy. Okay.
Well.
Who was it? The chicken grass and the chicken roast. What was the one that we were completely wrong on? I just, so just hard to do it.
It's like, wow.
You know, you keep it all the time. It's constantly stuff. Oh my goodness, what on earth am I doing?
Yeah, it's like, why?
Don't bag on people for spelling. I can do some wicked math, but my ability to spell flatlined in 4th grade.
The word was completely spelled wrong on purpose just because it was putting just left it on the board for like 2 days. It was, I can't remember what it was.
Hey, this one got really great.
Just all the vitriol in here. Jeez.
Stuff like that. Structure is such a scam.
Four minus 5 ninths is 36. Minus 5 ninths is 31 ninths.
I will sue.
You can sue them for not
How about we do the problem?
In the United States government, you can sue for over $15. I'm proud of you for knowing that.
Yeah, why do?
I don't know.
How come I always like do this?
I don't have one. What is that? I'm currently multiplying 2 times 7 over 9.
Why? Why are you like me about it?
Not though.
Multiply it.
But it's only for
Yeah.
but
I do not want to add 3
3. Since it's 25 by 50 minus 1, so it's 25 by 25, 625. 625. Oh, not from beginning to end, but the fractions definitely.
There's no way this is. Did you make
620. So it's going to be
Oh, 581.
5 by
Well, mine's gonna
2
be wrong, but it's
is 1250. 1250 minus that is 1225. 1225. And that is 1425 is 1465 is 1468.
Minus 25 nice.
You need your fingers.
this is so horrible.
5.
Or 2581. So take it like 8100 divided by 4. It's going to be 2025. Ooh, that distribution is going to be, that's going to be something. Okay, get to the quadratics. As long as you get to the quadratics, just stop there.
But my quadratic.
Just the quadratics.
Yeah, mine's already wrong. Mine will do it.
Get to the quadratics.
I think I need a big one.
Because I don't know if that constant term on the second one is reducible, and if it's not, the distribution of this is going to be bad.
1,468 over 2,025, and it is not reducible.
I did it.
Oh, really?
That's a shot.
I actually tried it. I kind of quit.
Wait, what did you say?
1,468 over 2025.
He's right.
I checked.
And that was fractions without calculators, and I got the same thing. So what's that? 6 and 36.
What's right now? Yeah.
was that 1468? Okay. If you can get there, you are one with the force. We will assume that you can finish it off and the force is one with you. All right. Can you do all this multiplication if I don't do that? So, for example, if on Tuesday I gave you something like construct the quartic polynomial that has 3 minus square root of 2 and 4 plus root of 3i as zeros, could you do that? Probably question mark?
As long as those are even.
If it's like this and not like that, are we okay? All right. So you can tell it was just kind of twitching a little bit, like must finish, must finish, must finish. Okay. Oh yeah, it's going to be fractions all over. Oh, even worse is pay attention to the directions of these kind of problems. They usually say find the polynomial of least degree with integer coefficients. So at the end, you're going to have to multiply so you don't have any denominators.
Yeah, well, I'm not doing that. I'm just
How about no? All right. I just wanted to see if you can work with the cheater and the radicals. You good? Here we go.
Oh my gosh, 45,000.
Over to example 7. Example 7, come on now. Ready? Y'all, just put it aside. It's okay to not finish things.
He needs this.
All right. So, you may have seen the direction line yesterday if you actually did the homework. I had said just solve these particular problems. The directions had go do all of the things. Go do the rational root theorem, go do the Descartes, blah, blah, blah. And then they wrote the directions, write it as a product of linear and irreducible quadratics. An irreducible quadratic is a quadratic that can't factor with rational factors. So if an irreducible quadratic, for example, is something like x squared minus 2x plus 2. That is an irreducible quadratic because what factors of 2 add up to -2? None, because that one had imaginary zeros. So if I say write it as linear and irreducible quadratics, I'm saying I would like you to put something like this. That would be linear and an irreducible quadratic. Okay? Now, notice after that it says, and a product of just linear factors. So now you would need to turn this into its two linear factors, even if they're nasty. Okay? So it's kind of putting all of this stuff together in one big bundle. Can you find all the factors and all the zeros? Now, this, you got to do the split method again. We're not going to do that. Could you find the zeros of this? Most of us, since we're shaky on that split method, you just got to kind of guess and check. Most of us are going to say, all right, 1x to the 5th, 0x to the 4th, -18x to the 3rd, 30x squared, negative 19x, and 30 constant. And we're going to gaze into that crystal ball and say, what do we feel lucky about? What do we think if we did all of that stuff that they want us to do, but it's the 21st century, so we're not going to do? We feel good about -5? I heard a -5. Man, there's just this voice speaking to me from the ether, and it was right. I guess we should continue listening to the voices in our head. What else do I feel lucky about? 2? All right, for some reason I feel lucky about 2. Man, this is going so well. What else do I feel so lucky about? For some reason, I don't know why. Don't ask me why. We're going to go to that mountain. And all of a sudden, I don't really feel lucky about too much anymore. Because, what is that last one? 101, when I turn that back into polynomial town. X squared plus 0x plus 1, which is a sum of squares, and sum of squares have imaginary answers. So I will write this as a product of linear, or hold on, there we go. K of x is linear factors. If -5 is a 0, x plus 5 is a factor. If -2 is a 0, then x minus 2 is a factor. If 3 is a 0, x minus 3 is a factor. And my irreducible quadratic at the end was x squared plus 1. Because that's sum of squares. Now, thankfully, I know how to deal with sum of squares. If that was x squared minus 1, I would call it x plus 1, x minus 1. The only difference when this becomes sum of squares, I'll subtract 1, square root, they're going to be i's. 1i, -1i. Because now when I move that over to the other side and solve by square roots, I got a negative in the way. So you write the same thing out. You say k of x is your linear factors. Come on now. X minus 2, x plus minus 3, and it's minus. And I'm going to turn this now into x plus I, x minus I. Now it's the linear factorization. If you are ever asked to find the linear factorization, this is what they want. Everything's got to be linear. Don't you dare have x squared or higher in there. If they say find the factored form, this is what they're looking for. And then finally it says find all the zeros. Got to catch them all. X is -5, 2, 3, plus or minus I. Okay. So we okay with that definition of irreducible quadratic? It's just the quadratic that ain't going to break down nice? Okay.
It's not free, but it's on there.
These two need to catch up.
Yeah. Yeah, I was doing.
My brain.
Well, that was a choice.
My
Yeah, it
brain,
was a choice.
My brain can't let things go.
I know.
Now I gotta reduce these.
Okay. So you're going to do the same thing. Let's start with this guy. And I'll tell you that this is factorable right now without splitting a term. It is factorable without splitting a term. That is something we do need to know how to do. I'm not going to require you know how to factor by the split term method because it's a guess and check, but I will say you got to know how to factor these. I'm going to show you both. I'll show you the synthetic division and the factored. Oh, that's right. Were any of you the gluten-free kids for Pi Day? No? All right. Mama Bear's asking. Tuesday. Oh, yeah, that is quiz day. No. We're actually about a day behind of where I want to be right now. So, no. Yeah, last semester was a dumpster fire.
This one's just be like a less bad thing.
I don't want to miss any time if we can avoid it because I would much rather give us days off when sophomores and juniors are testing next month. Pre-ACT.
Is that required?
Yes, all sophomores take the pre-ACT. I think it's only in the afternoon though, so we shouldn't miss this class. But it is? Hmm. It's just like the ACT, it's just toned down to sophomore content. It gives you an idea of if you continue on your current academic track, this is your predicted score on the ACT. A lot of schools aren't requiring ACT or SAT for entrance anymore, but prior to the world collapsing, we were looking at most four-year schools wanted a 21 or higher on the ACT for entrance because 21 or better on the ACT correlates to a 75% chance of getting a C or better in your college freshman classes.
What's the highest?
36.
What?
The difference between a 33 and a 35 can literally be one question because they get weighted higher when they're higher complexity questions. Yeah.
How many questions is it?
But it's a good multiple choice test
How many
where each section, what is it? English comp, English lit, science, math. They don't have the social studies. That was a pilot program. Each one of those sections is about 30 to 60 questions, is about 45 to 90 minutes. It takes the whole day.
Math is 60 questions in 60 minutes.
Yep.
Reading is 75 questions in 30 minutes.
And that is the. That's why we have so many kids who have a 4.0 GPA, but they're getting a 24 on their ACT. It's because, no, you are not really a perfect student because no one is perfect. But you've done enough extra credit and played the game well enough to look perfect. and then they go and get a 24, 25 on their ACT, and they have a crisis of identity because they put their entire weight of their personal worth on performance. Anyone feeling a little uncomfortable in their seat right now? Yeah. All right. Most of us, they are norming data for a new version. That's why. They can't just throw a test out there. They have to collect the data on it to make sure that it's valid. If I put a 1, 1, negative 26, 4, and negative 120 in here, most of us are going to go with this method. We say, I feel really lucky about what? Someone feels lucky about a 6. Or negative 6. Okay. I just heard this voice in the ether, and then a bunch of other voices started yelling at it. It was weird. Negative 6, negative 5, 34, negative 24, negative 20, negative positive 120. Well, all of the yelling voices were right. Apparently, the entire live audience of The Price is Right is now in the afterlife. What else do we feel lucky about? $5, Bob. 5 by 1 is 5. Add them together. And 4. 5 by 4 is 20. Yay. So if I'm going to write this as a product of linear and irreducible quadratics, then I'm going to say x plus 6 with a x minus 5. And then that part at the end says x squared plus 4. This is product of linear and irreducible quadratics. The only difference when it says now do the linear factorization is I can turn this into what? What's this guy? So if x will equal plus or minus 2i, this part can be replaced with x minus 2i, x plus 2i. That's why sum of squares, this is the linear factorization. So stage 1 is write the product of linear factors and irreducible quadratics. Second stage is, okay, that irreducible quadratic, actually write it with the nasty factors. And then the third stage is, tell me what all of the zeros are, in this case, negative 6, 5, plus or minus 2i. Now, I know this is how most of you are going to do it. Some of you who are planning on going further, and I am going to bring this back later as a review problem on test, just because we need to know this. The factoring version of this, you just isolate the quadratic forms within it. If I rearrange this there and here, all I did was take that same polynomial and I rearranged it, right? Addition's commutative, I can do that. Now do you see where the factorable parts are? Okay, this one is quadratic form. Factors of negative 120 that add up to negative 26 are x squared minus 20 and x squared minus, oh, wait, bad. Let's try that again. X squared. What factors of negative 120 add up to negative 26? 30 and 4. Over here, if I take out an x, I'm left with x squared plus 4. I see that they both have an x squared plus 4 in common. I take it out. And when I do, I'm left with this and this, so I got x squared plus x minus 30 as a quadratic. Factor each. This is sum of squares, x plus 2i, x minus 2i. Factors of negative 30 that add up to 1 are x plus 6, x minus 5. You can factor these. Okay? And then plus or minus 2i, negative 6, 5. I mean, you have to be forceful stopping me. My reaction time is terrible. Unless it involves a falling child, then it's like supernatural. It's a parent thing. Like, I have been sitting on the floor next to my couch and a kid just like dives off as I'm talking this way, and I just kind of catch him. I have caught my kid by the ankle upside down before as he falls off of things. He was up on the kitchen counter.
Oh, so you brought him lower, not like literally caught my ankle.
No, he like, whee! And I caught his ankle before his head hit the ground. It was something like that, yeah. I mean, he still thumped his head a little bit, but I slowed him down enough. Okay. This is factorable. I want you to try. I know that you can do the synthetic division thing. I want you to try factoring. Y'all put all of the odd degree stuff together, put all of the even degree stuff together. It is factorable as is right now. It takes multiple steps. This is going to be like 7 lines worth of work, but it is factorable.
Sadly, so much.
We're just gonna write stuff.
They're old notes. I used to have a lot less room in my notes. I did not want to use the new notes from last semester because I didn't like their lack of graph analysis.
How do you start?
All the odd terms together, all the even terms together. No, like you just rearrange it. So x to the 5th, x to the 3rd, x to the 4th, x squared, constant. And then those 3 and 3 terms should be factorable as is.
I got 32 of them. Yeah, I didn't. And then I got.
Do this problem.
I was.
I need to make sure it's right. We'll do it all for you. Can you stop talking to people like that? You don't need to say that, boy. Never say that. I'm like Gatsby, old sport.
She might be crazy.
Once you kind of start breaking it apart like this and you see the quadratic forms, We should be okay after that.
We'll just. Don't you have? Would it one of your factors be extra? The 6 and not go anything. Because you pulled up the.
X cubed, negative 11x. Negative 2x squared plus 12. I found a quadratic I'm able to take out. Now I got to deal with this guy.
Couldn't you just factor this on the kill? That's another shit.
But then they're not going to have anything in common to continue taking out.
But you just need to find the zeros. So you just factor each of those.
But this is no longer a string of factors. It's a difference. It's only if it's this times this times this times this times this that I can set it equal to 0. You got a split method after that.
Yeah, then
Okay.
Were we supposed to measure?
Factoring the larger polynomials, as soon as you introduce that split method, gets very sketchy. Okay, so factors negative 12, add up to 1, so x plus 12, x minus 1. It does keep going. X squared minus x minus.
You said 7 lines of 4 minutes to 9.
Sorry. I didn't know that there was a split method at the end. So, if you can't get all the way through orange, that's cool. Can you do this long chain synthetic? All right. This is the difference between I can get through this chapter, I can get through this section, I can solve polynomials, yes, versus I can keep going, bring on Calc 3. Okay? This is not something that's in our textbook. This is not in any high school textbook all the way through our trig and calc classes. Because it's possible and I know you can do it, and I have kids every year who go further on and they come back and say, how come you never showed us this? I'm showing you it's possible.
So how do you know what to split?
Guess and check.
That's horrible.
There is no algorithm for it.
It's really easy with a column solver, because then you can just.
Yeah. Okay.
So you split out, like I did, because like I never would have put that, I would have just.
Because like I sometimes
But
find
once
it
you
like
get here-
that way, then it's like there's too many.
Oh, you can't just solve them separately because they're not being multiplied together. You can't set them equal to 0. Remember, you set things equal to 0 to solve because they're factors. If this times this equals 0, then this or this can equal 0. Set them to equal 0, solve. As soon as you throw this in here, these are no longer being multiplied. So you can't set this equal to 0 and this equal to 0 because they're not times each other.
I have a question, when you pull out the x squared minus 9, they're then multiplied?
Now, there's no plus or minus in between these. So now I could set this equal to 0 and this equal to 0. Because now they're factors instead of difference. That's tough stuff. Okay? That is very tough stuff. You will not be required to factor something that requires a split method. This guy right here. But factoring by grouping, were you able to get to blue or even green? If you can get there, you have the skills you need for everything you will do in here and the next 2 classes at our high school. Okay? But if you plan on going Calc 2 plus, you will have to do the rest. And it's just like the difference from Algebra 2 to PreCalc, dialing up the complexity, right? It's the same skills, we just dialed it up. You need to be able to do this in PreCalc. You will need to be able to do this later. Okay? I'm just showing you. So, cutting off there. I smell burnt wiring.
My wife was posted after that goofy crime problem.
I'm pretty sure you're doing wrong, because mine wasn't here. I didn't go all the way. This isn't true.
Oh no, once I saw the fracture.